Hello, this is my little project with sending data over audio waves using my computer speakers to send the data and the computer microphone to receive the data. And then I use the web audio API's analyzer to evaluate the different frequencies that came through with their amplitudes and translate that back into a stream of the original data. Uh, what we have today is what do we have? Periodic interleaving. So I added this little checkbox here, and basically, what this does is it scatters your bits across the different channels. So usually I'll have one channel that's pretty bad, like you'll see channel number 9 has a lot of problems. It's not that bad if one channel has problems, but since I have a bit here that's within the 7-bit range of an error block, this is not good because this means that an error block consisting of 7 bits cannot recover the original data if 2 or more bits come through wrong. I can only recover if I have only 1 bit that's wrong. So what periodic interleaving does is it'll move these bits and shift them into the next error block. It'll like swap out blocks between each other to make sure they're at least 7 bits apart. So this one would stay in channel 0, but this one below it in channel 1 would move to I believe it would be channel 8 is 7 bits away. And then the one in channel 2, I think would move to, is it 15? So with each additional bit, it gets moved to X number of error blocks away. And it just cycles through continuously. So this will be 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3. So it'll kind of repeat that pattern of what channel block it is. Just because I'm often finding what is it that I'm finding? There are often bits that fail very close to a failing channel. All right, so in addition to periodic interleaving, I went ahead and added the ability to turn off channels. So I'm using channel 9 here. So if I go down here with all these check boxes, I can uncheck channel 9 and send the signal again. Look at that, error percent 0. And this error percent 3, don't trust it. Because there's no errors here. The error is actually this extra dot, which is not even, so it ends with C5 over there. Somehow it's adding a dot, so I'm not worried about that. But you'll notice down here, it jumps from channel 8 to channel 10. It skipped the channel. And it says there's 18 channels, but 18 plus 1 is actually 19. So there's only 18 channels that I'm actually using when there are 19 channels available in the frequency spectrum that I have selected here. Last and least is the waveform. So give you the ability to change your waveform to a sine, square, sawtooth, or triangle wave. I ran about 10 tests on each one. It seemed like the triangle wave did better, but it was so negligible that it really doesn't make a difference. So it's just one of those things I just need to see, did this actually make a difference? Yes or no? I might as well test it because it's available. Um, yeah, I think the next thing I'm gonna look into is data compression, specifically the Hoffman coding. I was looking at how that gets implemented and the the technology of how that works. So I'm gonna look into seeing if I can implement it, and if there is, if it has benefits to compression, then I'll just include it. Um, yeah, that's it for today.